right, so we've talked about linear regression, we've talked about quadratic regression, we just keep moving up the degrees of the polynomials. Today we are going to talk about cubic and quartic regression. So cubic is degree 3, quartic is degree 4. And our learning goal for today is to be able to use regression on the graphing calculator to write a cubic or quartic function that will fit a set of data. So, first here in example 1, we want to use finite differences to determine the degree of the polynomial that will fit the data. So, we do the finite differences first. So what we did in 6.9a, remember it's always right minus left. So negative 2 minus 6 is negative 8. Negative 32 minus negative 2 is negative 30. Negative 96 minus negative 32 is negative 64. Negative 206 minus negative 96 is negative 110. And negative 374 minus negative 206 is negative 168. So there's our first order differences. So continue on. Negative 30 minus negative 8 is negative 22. Negative 64 minus negative 30 is negative 34. Negative 110 minus negative 64 is negative 46. And negative 168 minus negative 110 is negative 58. So there's our second order differences. So now third order differences, negative 34 minus negative 22 is negative 12. Negative 46 minus negative 34 is also negative 12. And negative 58 minus negative 46 is also negative 12. So this is the third order differences that are constant and non-zero. So that means that the degree of the polynomial is the third degree. So that means we are trying to find a cubic model for this particular data. So after you do the finite differences, then we're going to enter our data in L1 and L2. Remember that you want to clear the data out first if you've already got data in there. So to clear out, you press Stat and then choice 4, and then tell it which lists to clear. Once you're ready to enter the data, remember you press Stat and then choice 1 for edit. So now we want to enter the data. So we're going to make our X our L1. So we're going to hit 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. And we've got all of our X data. Now our F of X data we'll put in L2 and just go straight down the list, starting with 6. Make sure that the data points match up and double check that they are the correct values, because most of the time when people get wrong answers, it's because they accidentally hit a wrong button in entering the data and didn't check it to notice. All right, so since it says it's cubic, that means we're going to be doing cubic regression. So right here, in order to do cubic regression, it's the same buttons we pressed for linear and quadratic. You're going to press Stat. You're going to scroll to the right to the Calc menu under the Stat, and you are going to choose choice 6, which is cubic regression. So again, depending on which type of calculator you have, if you have the detailed screen where it says X list, Y list, and all of those things, that's great. Otherwise, you might have to tell it which lists you're using, so pay attention to that, and either press enter once you've got it for L1 and L2, or scroll down and press enter over the calculate. And it says that A is negative 2, B is 1, C is 3, and D is 4. So that means we write Y equals A is negative 2, so negative 2x cubed, plus 1, so plus x squared, plus 3 is my C value, so 3x, and then D is 4. So negative 2x cubed plus x squared plus 3x plus 4 is our model. So let's look at another one here, example 1b. Finite differences, 2 minus negative 2 is 4, 12 minus 2 is 10, 28 minus 12 is 16, 50 minus 28 is 22, and 78 minus 50 is 28. So that's first order differences. Second order, 10 minus 4 is 6, 16 minus 10 is 6, 22 minus 16 is 6, and 28 minus 22 also 6. So here it was the second order differences, so it's going to be a second degree. So just because we're in cubic quartic lesson does not mean we can't go back. This model should be quadratic because we had the second order differences. So again, you want to clear out your list so that you can enter your new data. And we want to put that data in L1 for x again and L2 for f of x. So go ahead and enter that data. All right, should be getting pretty quick at the data entering by now. Again, because this is quadratic, that means we're going to go, once we've got our data entered, press Stat, and then scroll right to Calc, and you're going to choose choice 5 for quadratic regression. And it tells us that A is 3, B is -5, and C is 0. So that means our model should be y equals 3x squared minus 5x. You do not have to put a plus 0 on the end of that. So that will be our answer. All right, last one. The table shows data on the increase in girth of a tree in a redwood forest over a 10-week period. Find a quartic model for the data. So it's telling us we don't have to do any finite differences here. It's telling us to use quartic. So that means, again, you need to clear your list so that you've got your L1 and your L2 free to put in this data. So we're going to put weeks in L1 and the increase amounts in L2. So go ahead and enter the 0, 2, 4, 6, 8, and 10 in your L1. And all those tiny little decimals, again, please double check after you enter to make sure that you haven't made a mistake in entering, especially when the numbers are this close together like they are here. So double check your data, double check that it matches up. Now to find the quartic model, that's right here. So we're going to press Stat, go to Calc, and we're going to choose choice 7, Quartic Regression. Again, make sure you tell it what lists you want. So if you used L1 and L2 like I did, tell it that. Otherwise, tell it something else. And then press Enter or scroll down to Calculate and press Enter. And you should get something that looks a little bit funny. As you look here, you get your A. It says 3.776 and then it says E -4. Now we have talked about this a lot of times and I have told you that this is scientific notation, and on zeros when we see this we always say, oh, that means it's 0. Now here we don't want it to be 0 because we need an actual number as our coefficient, so we're going to actually have to do the scientific notation. So it's 3.776. E to the -4 means move that decimal place 4 places to the left. So 1, 2, 3, 4. This is where the decimal point would go. And so you'd have 3 zeros in the space after the decimal point. So that means we've got y equals 0 point, and again 3 zeros after the decimal point. And then we can round that 3776 up to 4. So again, this is a quartic model, so that's x to the 4th. Now the other ones look okay. B is -0.007 approximately, and that's my x cubed. C is positive, so plus 0.03, and then we can round that up to a 3, I would say, and that's x squared. Our x value is the d, and it's negative, so minus 0.037x. And then, of course, I'm running out of room for my e, but it's plus 0.340 because we do not round that one up. So there is our model. Oops, and I should have put that in part A. Sorry about that. That's our model. Then it says, use the model you found in part A to estimate the increase in girth in week 5. Now, week is your x variable. So yes, you're plugging in x equals 5. However, if you haven't been using this trick already, you probably want to do it now that we're at Quartic, because this is going to be a lot of work otherwise. If I plug in that 5, I've got a lot of multiplying to do, a lot of pressing in my calculator. But if I use what I learned in the quadratic regression lesson, and I go back to my stat calculate menu, and I go to the Quartic regression, and I store my regression equation. So again, on the older ones, it just means that when you do the Quartic regression, you do L1, L2 with commas, and then do the Y1. Again, if you've forgotten how to get this, the directions are in your quadratic regression notes, but you press the vars key for variables, you scroll over to Y variables, you choose choice 1 for function, and then you choose the equation. So again, we would choose Y1 because we don't have anything else stored there. But what this allows you to do, other than looking at the graph as with its equation, and in order to look at the graph, remember, look at your y equals, because the plot needs to be on as well. But what this is going to allow you to do is it's going to allow you to look at the stat plot and to look at the equation together, but also it's going to allow you to use data to predict using your second calculate menu, which is something we really, really, really want to do. So what I'm going to do here, and I'm going to change my window to match this. So on my x's, I'm just going to go from, let's say, 0 to 11, so just above the 10, counting by ones. On the y's, I'm going to go from 0 to 0.5, and I'm going to count by 0.05. You could count by 0.1 as well. But the reason I'm going to do that is because it's a very small numbers here, so I only need to see part of it. And you don't need to make anything fancy, just a rough sketch of what it looks like to make sure you're on the right track here. But the model looks something like this. So if I want to find x equals 5, instead of having to plug all this in and simplify it and worry if you made a mistake somewhere, you can just do your second trace menu. So do second trace and choose choice 1, value, and tell it that you want x to equal 5, and then press enter. And it's going to spit out the answer for you. So it's going to tell us that y is about 0.35277. So if we're rounding to the nearest hundredth like all the other ones, it'd be 0.35, and our label should be millimeters. So that would be our answer for part B. Now C, you really, really want to have this graphed in your graphing calculator. In which week was the increase in girth about 0.25 millimeters? Now, that is giving you the y and asking for the x. So it's telling you y equals 0.25. Now, if you plug in y equals 0.25, we don't really know how to solve that because that's not factorable. So we have to use our graphing calculator here. What you're going to do is you are going to graph y equals in your y2 you're going to graph that equation and use your intersect feature. So you're going to use your second trace intersect. So that means you need to go to your y equals screen again, and in your y2 you need to just press in 0.25 because it's y equals 0.25. So you're graphing it along with this graph that you already have, and when you do that you should get a line that looks something like this, and it wants to know in which week was the girth about 0.25. Well, there's two intersection points, so I'm going to find both of them here. So you do second trace intersect, which is choice 5. Remember, you have to move your little cursor near the intersection, and then when it says first curve, press enter. When it says second curve, press enter. When it says guess, press enter again. The first one, you get x equals 6.900. On the second one, and again, you have to make sure that you move your cursor close to that other intersection if you want it to give you a different answer, a different intersection point than the first one. But the other one gives you 10.62 approximately. So we have to decide between these two. And if you look at the data that they gave us, it only went up to week 10. So we can't report on something as if it's already happened, if it might be something that's in the future. So we can't include this one because it's not in our data set. Now, if it had said predict when the increase in girth would be this, then we might be able to include it, but it says in which week was it, so already happened. So 6.9, we round up, so we're going to say that in week 7 is when it had the 0.25 millimeter increase. All right, that is it for today.